Hello, this is Tyler Gakstatter with Anatum-TylerGakstatter Solutions. I'm going to show you today how you can obtain high accuracy GNSS offset solutions in Esri's ArcGIS Collector app running on iOS. You're going to use an EOS AeroGold RTK receiver and a TruePulse 200X laser rangefinder from LTI or Laser Technology. And we're going to combine those two instruments together along with Collector to obtain these GNSS offsets. It's a very slick solution for Collector. It's not built in. It actually requires the Aero receivers, in this case an AeroGold, and it will do all the computations for you and then send the final result to Collector. Now there are three different offset solutions. There's standard laser offset, there's range, which is what you're looking at here, and we've got range backsite. Range backsite is the most complex, but also the most accurate solution. It actually requires not only the 200X, the gold, but a true angle, which is a turn angle device providing super accurate angles. And so while that is more accurate, it's also more equipment to carry around. This is a great solution as it's light and it's easy to use and it's very quick. With the range backsite solutions, it's like a total station setup, requires more time on the front end to set up and get set up on your control point and to where you can shoot assets from there. But with this solution, you don't need to set any kind of backsites. There's not a whole lot of setup to it. You can just get your range pole set up, get these Bluetooth connected, and start shooting your assets. So today I'm going to walk through the whole workflow of range for collecting 1 point. I've got a monument set up on the curb over there. And so since we need to shoot it from two separate spots, I'm going to shoot it once from here, and then I'm going to move down there about 15, 20 feet or so, shoot it again, and then we'll look at the results in the Collector app, and then we'll also look at the results in ArcGIS Pro compared to our control point. So let's get started. I've already got my 200X Bluetooth paired with my iPhone. I've already got the AeroGold Bluetooth paired with my iPhone, and it is streaming RTK corrections from our RTK base running on our office. So, and I've got those in Collector, and we got GPS accuracy of 0.01 inches. And so let's collect a point. So to do an offset, you just start normally as you would in Collector, hit the blue plus sign, and then instead of hitting update point, you'd hit the 3 dots, select offset from location, and EOS Tools Pro will run you through each step of the offset process. So at the very top, we have measurement method. We select range, and then we go to step 1. So it's asking us to log our GNSS control point number 1. So since this is our first station, I'm going to log its position, make sure you're bubbled up, and then hit the start button. Let that average for 5 seconds. Click next. Now, number of targets, we only have that 1 point, so I'll hit next. And then we're going to fire at the target. So to do that, actually, I want to reposition this a little bit. And as long as that tip doesn't move, I can rebubble it. It should be fine. If I really want to get the best accuracy, what I could do is I could resurvey in my control point. Show you how to do that. You just hit back, hit start, just let it average again. This will just allow me to easily see it from this angle. So let's hit next, and now I'm going to use my laser rangefinder to zone in on that control point. Press and hold the fire button until I get a result, and you see the values in the fields. Now I hit next, and it's asking me to log GNSS control point number 2. So I'm going to pick up this whole setup, move it down 15, 20 feet, and do that process over again. All right, right about here will work. I'm going to put my bipod legs in the ground. I'm going to bubble up. I'm going to hit start. Log my next GNSS control point. And then it's going to ask me to shoot that asset again. So I'm going to click next. It's waiting for me to shoot it. aim, and fire. There we go, we got a result. You hit next. And now it's gonna ask me which solution of two is where the monument is. So normally in say like triangulation, you would have 3 base stations or control points to choose from, and then you could find out accurately where your spot is. Well, in this case, we only have the 2 control points, and so I need to tell it on which side of those 2 control points my monument is. So I can use this globe in the bottom left to bring in the imagery, and I can see, since the railroad tracks are behind me, that I want point 2. So point 2 is red right now. I'm going to tap on that, make it green, and then I'm going to hit send. Now, EOS Tools Pro did all the calculations, curated all the information. It's just basically sending it a packet of information to collector. Once it does that, I just hit submit. And it's going to record that point right over the curb, as you can see. So let's go in to ArcGIS Pro and look at the results. Actually, you know what? Let's look at this little pop-up first. So the solution not only gives you an accurate point, but it will also capture a lot of GNSS metadata information with it. So let's take a look here. Let me get back in the camera view. And let's run through this real fast. So we've got receiver name, Arrow Gold GNSS, and it has the serial number of this particular receiver. It tells me the measurement method, so I know that I use the range. Then we've got the final latitude and longitude calculated by EOS Tools Pro offset. We've got our orthometric height, our ellipsoidal height, even the geoid separation value, which is the altitude undulation, record of our geoid model, the laser device, which is 200x in this case, and basically all of the information used by EOS Tools Pro to calculate our offset position. And so you've got a good record of not only your final position, but all the numbers used in that process to calculate it. Now these fields are empty because that's part of the backsite solution. So if I was using the range backsite solution, those would be populated, but in this case they're not. So not to be worried if those aren't populated. And we've got our other control point values and our final elevation orthometric height at the bottom there. And those 2 fields are actually using an arcade script to pull out the Z value from the feature because this is a true 3D solution. It calculates the final Z value and it actually goes into the geometry of the feature as GIS would expect it. All right, so that all looks good. And so let's go in and open up ArcGIS Pro and see what kind of accuracy we've got. Okay, now that we've got our laser offset point collected in the field using the range solution by EOS with our laser Tech TruePulse 200X and Esri's collector running on my iPhone, let's take a look at the result. So I've brought up ArcGIS Pro and I've pulled in the feature class used for the GNSS offsets. Actually, it's a feature service hosted in ArcGIS Online. Pulled that directly into Pro, and I've also pulled in a layer that represents our control point. And let's take a look. So if I zoom into the area where I captured that offset, you can see our features are right here on the curb. And for more perspective, the camera was set up right about here. My first control point was taken right about here. Second one was taken right about there. So if you remember the railroad tracks to the right of me, that's right there, and the cars on the left side right here. So let's zoom in and take a look at the accuracy. Here's our control point. You can kind of see the outline of the monument. It's a little bit offset. It's probably just due to the error in the imagery. This is actually imagery flown by us, by one of our drones. That's why it looks really nice. It's nice and crisp. But this is the actual position of that control point, and this is the position of our GNSS offset, or the result of it. So to give you an idea, let's do a little measurement. Let's keep it on metric and snap to that feature, snap to the control point, and we're looking at right at about 6 centimeters, which is pretty good for that offset solution. Not a lot of equipment we got to carry around. Essentially, it's just a normal RTK range pole setup with a TruePulse 200X attached to the pole. It does require 2 shots per asset, but with this type of accuracy and the limited equipment we have, it's a really good result. Not only do we get good accuracy, but as we saw in the field, we get all this nice information with it too. We have just about everything related to that offset stored in this feature. Now, as long as these fields exist, they will be populated, so you can kind of control which information is stored with it. We have a script available that will automatically add all of these fields to your feature class, just to make it easy for you guys. But if you wanted to get rid of some of these, say if you were only doing the range solution, you never did the backsite, you could get rid of all these backsite fields because they'll just be null most of the time. Well, all the time if you never use backsite. But all the other fields are populated. So like CP1, this data set represents all of the information that's related to our first control point. So this would be the latitude, longitude, and altitude of that control point from where I shot the asset. And then CP2 would be the same data set, but all these values will be related back to the second control point. So it's a good record. You can actually manually calculate the offset with these values. It's just good to have that recorded in there just in case you ever need to audit it. All the information above that is related to the final position captured with the offset. So the receiver used, measurement method, the latitude, longitude, and then the various heights. We've got the ellipsoid height and the orthometric height. Also the geoid separation value used to obtain the orthometric height, which came from the geoid model 18, as you can see here. And then our Bluetooth laser device, or 200X, and also the settings used for our laser setup. So in order to get accurate positions, you need to tell EOS Tools Pro what your antenna height is. So this is 2.034, that was my antenna height for that setup. And then my laser device height was 1.6 meters, which I measured manually and then inputted in that before I took that offset. Magnetic declination, that's automatically grabbed from the RTK receiver based on its position. And yeah, so you have the option to capture all this information, or if you want to delete some fields, that's okay too. It'll just populate whichever fields are available. Now this is only one offset solution of 3. So EOS has a standard laser offset, this one which is range, and the range backsite. They all result in kind of the same thing, a point like this with all of this information. It's just a matter of how that point is collected in the field. And as I explained earlier, each one has its own benefits and drawbacks. Range is probably one of the most popular solutions just due to its accuracy, balanced with the amount of equipment you have to carry around and the ease of workflow. So if you have any questions about the solution or want to get a demo or just some other information, feel free to contact us at Anatum-TylerGakstatter-EosGNSSOffsets. I will have my contact information as well as my other colleagues' contact information at the end here. Hope you got something out of this demo, and enjoy.